Guys, what's up? My name is Steven. I know a little bit about HVAC, and I'm going to share my information or my knowledge with you. So I got a call today from my buddy Brad, who was at the store and wondering what size or what type of furnace filter he should buy for his furnace. All right? Does he buy like a MERV 8 for 20 bucks? Or does he buy the MERV 13 for 35 bucks, right? Is the more expensive filter always better? How do you know which one are you supposed to buy? Maybe you don't think about it, you just buy the cheap one, or maybe you don't think about it and you always think more money means better filter and you buy the most expensive one. How do you know what you should buy? And a disclaimer, or I should say spoiler, it's not always the most expensive filter that you should be buying for your system. This video is going to explain to you what one you need and why, and it's more complicated than you think. Folks, my name is Steven. Welcome to the channel. I'm going to talk today about HVAC furnace or air filters for your furnace. So behind me here is my furnace, okay? I got this thing with the house. It was installed in 2009. I got the model number written right on here. I got the serial number and the order number. It's a York furnace by Johnson Controls. There's so many different manufacturers here in this stuff, guys, it just makes me confused. Anyway, once you turn the power off over here on the side, click, now the power is off. Now I'm safe to open this sucker up. Get her open here. There's the top part off, and here's the bottom part off, okay? No big deal. Right now, for the sake of our discussion today, I want to bring your attention down to this lower compartment. Now, my furnace is an upflow, so air comes down the return, sucked down here, comes over here through the filter. The filter's right here. I got my hand on it, folks. It comes through here, then it gets pushed up through the heat exchanger, up through the coil, and out the supply there. Okay, so it goes whoop, like a big U. So down here, guys, this electronic board, you can kind of see it's like yellow. This is the electronics for the machine. Now, behind this electronics board is a blower motor. It's like a big fan, okay? And the job of the fan is to do one thing. It's to move air. It pushes air. And it's rated with an acronym called CFM. It stands for cubic feet per minute. Now this fan can run at different speeds. It's got a yellow wire coming off the fan, there's a red wire coming off the fan, there's a blue wire and a black wire and a white wire. There's a total of 5 wires coming off this fan. Okay? Each of those wires set the fan to operate at a different speed. So right now, on my control board, I've got the yellow and the red ones are in the park positions. Those mean they're not being used. The blue wire on my system is going to cool, and the black one is going to heat. So I can open up my manual for this furnace, and in there it'll tell me if the blue wire, like the blue wire will say it's like medium high. And it'll tell me how many CFM this speed tap is pushing. I'll say that in another way. The blue wire will make the motor spin so fast, and the red wire will make it spin slower, and the yellow wire slower still, and maybe the black wire will be the absolute slowest or something. So each of the wires mean that the motor is going to spin at a different speed. You need to know what speed tap your blower motor is on. And you do that by coming in here and seeing what each is hooked up to. So I've got blue for cool and black for heating. And then you need to go into the manual to see how many CFMs your blower motor will push when it's on that speed tap. Okay, so you got that? Let's just hang on to that. Let's put that on the side. Now let's move on to something else. Why do you care about how many CFMs or units of air your blower motor is pushing? Folks, this is the answer to that question. You live in a house and you want to be comfortable. You want to be hot in the winter or warm in the winter and cool in the summertime, okay? So if you want to be, let's just talk winter, okay? I live in Wisconsin. It's a heating dominated climate. If you want to be warm in the winter, you want warm air coming out your vents, and you don't want cool air coming out. The warmness in the air, or the warm units, are delivered by the CFMs. So think of it as like the kids get to the school on the school bus. The school bus is the CFM. It is the airstream. It's the airflow. Heat, which is the kids, ride on the airflow to each of the rooms. You need the CFM to deliver the heating or the cooling to any room in your house. Now, not all rooms in your house need the same amount of heating. For example, if you have a south-facing room with a ton of windows, even in the wintertime, on a winter day, it's going to be warm in that room because of all the solar heat gain that you're getting through those windows. Or even more, if it's a bunch of windows in that room and the inside's all black, all that blackness is going to absorb all that heat and it's going to radiate off into your house then, all right? It's going to make that room really warm. If you have a room on the north side of your house, okay, with some big windows in the wintertime, that room's going to be colder than the south-facing room. So what I'm saying to you is that different rooms in your house have different airflow requirements. Different rooms in your house need different amounts of heating in the winter. South-facing rooms need less heating. North-facing rooms need more heating. Smaller rooms need less heating. Bigger rooms need more heating. And if a room needs more or less heating, that means if it needs more heating, it needs more CFM to that room. If it needs less heating, it needs less CFM to that room. Okay? You with me so far? So, let's go back to our discussion. You're over at the store and you're picking out a furnace filter. Okay? Right now, let's just suppose that my blower motor will push 1,000 CFM on this blue speed tab, okay? And let's say my house needs 1,000 CFM, okay? So it's perfectly matched up because I need 100 CFM for that room and 500 for that room and 300 for that room and blah, blah, blah. And all the CFM equals 1,000, and on this speed, my blower motor will push 1,000 CFM. Well, folks, my blower motor will push 1,000 CFM of air at a certain pressure resistance. In other words, when air goes through my duct system, it has to push against the friction in the ducts and all the corners and the turns and all that stuff. Like, picture yourself blowing through like a straw. You can only move so much air through that straw. If that straw had a bunch of twists and turns, you ever drink out of one of those straws that's like got all the loop-de-loops before you suck it up to your mouth? It takes more pressure to push air through a twisty-turny straw. Well, that twisty-turny straw is your ductwork. So if you've got crappy ductwork, that means your ductwork will have a high amount of pressure to push against. That's called having high external static pressure. If you have a good duct system, then you have low external static pressure, and that's a good thing. So back to my example, if I can push 1,000 CFM of air, and that's how much my house needs, well, if I put in a MERV 15 or 13 filter, that filter will increase the pressure in my duct system. And if I increase the pressure in my duct system, it will decrease the amount of air that my blower can deliver. I'll say that again just because I'm wrapping my mind around it too. When you have a greater static pressure in your duct system, that means your blower cannot deliver as much air through the ductwork. So, you know how many CFM of air your blower can deliver, but it can deliver that much air against a given external static pressure. And you only know what your external static pressure is by measuring. If you don't measure, you're guessing. And you measure with something called a manometer. So you need to have a manometer and to measure the external static pressure in order to determine how much CFM is going through your system. So if you already have high static pressure in your system, you don't want to put in a high MERV rated filter because that's going to increase your static pressure even more. And that's going to mean two things. Number one, less air is going to be delivered to each of your rooms. So that means less heating in the wintertime and less cooling in the summertime. And two, that's going to make your blower motor work really hard all the time, and it's going to burn out your blower motor sooner. Think of it as rather than cruising on the highway at like 55, you know, in like fifth gear, like nice and comfortable on flat ground, your blower motor's going to be going like up a hill in Colorado at like, you know, 5,000 RPM, like, I mean, you're like pushing it hard all the time. That's not good for the motor. Okay? So just to recap in case you didn't get it, or just so that we're all on the same page. Your house has heating and cooling requirements. The heating or the cooling rides on or is dependent upon the CFM, or it's dependent upon the airflow. The heating rides on the airflow. If you don't get airflow to a room, you don't get any heating to a room. Okay? So let's say your room needs 100 CFM of air to be comfortable in that room. Well, if you increase the pressure in your ductwork system, you're going to lower the CFM that gets to that room. That's why you need to be careful.